Hello, everyone. Thanks for attending my talk. My name is Andrew Yule, and I work for a company called Assured Flow Solutions. And we are a consulting company in the oil and gas industry. And today I'm actually going to be talking nothing about that. I'm going to be talking about a side project that I've been working on for a little less than a year now, off and on, and I wanted to share it with everyone in the hopes of kind of getting some more people involved with it. It is an open source project, and what it's basically looking to do is to kind of replicate the famous R ggplot package in the Wolfram language. So this presentation is going to talk a little bit about some background on that package that I just mentioned. And it's going to talk a little bit about why we need something like this in the Wolfram language. And then the bulk of this presentation, I think, will just be going through some examples of things that you can do with the R package and where the current Wolfram language package is in terms of matching some of that functionality. And then I'll conclude here with just a few remarks about some of the path forward. So the title of my talk is Grammar of Graphics for the Wolfram Language. So I wanted to start first with kind of defining what is the grammar of graphics. It was a book written by a famous statistician, I believe, that had this title, and ultimately that kind of became one of the most famous R programming languages packages of all time, which is called ggplot, and I'll talk about that in just a second. So the whole idea of a grammar of graphics is, as opposed to basically trying to define everything in your plot up front, you really take more of a layered approach to defining what is your graphic actually made up of. And so you can see, I think this is a good graphic I found on the internet that kind of describes that of what are the various layers that really go into graphics. And of course, you start first with your data, and that's the most kind of fundamental and most important part of what's going to go into a graphic. And then you can start to change things like aesthetics, which is how different parts of your data gets mapped to the things that the viewer actually sees in that graphics. And you can change things like the scales, the geometric objects, and then you can, as you get further up in here, you can get more and more fine in terms of some of the things that you can change related to your graphics. So what are the main advantages of this approach? So one of them is that really complex plots can become very easy to create. And another one is that creating visualizations, because it becomes a much more easy process, but also a more iterative process, it means that exploring your data can become much easier as well. So I've mentioned ggplot. So one of the first things I wanted to start off with is this idea of the data set. So in the R programming language, this is a data frame or a tibble or various other names for it, and this is kind of a common thing across a lot of the data science focused languages of having something called a data frame. Essentially, what it is your data set, and your observations are rows, and your columns are variables. Okay, so what is ggplot? Here's a really quick example of kind of what the syntax looks like. So you load it with this tidyverse command here. You take this data frame that you've got, and you say, I'm going to create a base plot. I'm going to say the aesthetics of that plot. I'm going to have my X mapped to this variable within that data set called displ, displacement. And my Y is going to be mapped to this other variable called HWY, which is highway MPG. Right. So that's going to describe the first kind of layer of this graphic. And then you're going to say, okay, and now that I have those aesthetics defined, I want to create geom. I want to apply a geometry or geometric objects to those aesthetics. And in this case, I'm going to create points out of that. And so this is really kind of your most basic XY scatter plot type plot here. Where things kind of get more interesting, and where you can start to see some of the power of this approach is in the aesthetics up here. You can not only add your X and your Ys, but you can also change things like color. And so in this case, I can map color to this variable called class. And then again, with just the geom point, and you get the same XY scatter, but this time you see various colorings according to the class of the car in this MPG dataset. You can take this another step further by basically adding another dimension to this data set, where you can say size is equal to this variable called cylinders. right? And then you get this nice, real clear visual of as you increase the number of cylinders, obviously your highway MPG is going to go down because you have more fuel that you're burning. So I mentioned this before. Data frame is kind of the fundamental data object that goes into ggplot, and luckily now we have a very nice system for that in Wolfram Language when associations came out, and in particular too when data sets came out. So this is kind of the equivalent of that here in the Wolfram Language. I can also show that in a data set form. So these are the two data sets that I'll be working with here in most of these examples. Okay, so this talk is in no way trying to diminish the functionality and the built-in visualization functions in the Wolfram language, because they are truly amazing, and what you're able to accomplish with those are really impressive. If you are willing to kind of force yourself into saying that we are only going to work with this structured data, though, there's a lot of shortcuts that you can make, and a lot of assumptions you can make that that can actually, I think, enhance some of the capabilities under the assumption that you're operating with that structured data. So, as an example, if I wanted to do, just recreate that list plot, obviously we can do that scatter plot. Obviously, we can do that with ListPlot. If I wanted to join that data for whatever reason, I could obviously add a joined. I could add joined equals true as an option to ListPlot, or I have to kind of know ahead of time, hey, that's a better thing to do with ListLinePlot, right? So it really requires knowing which function you want up front, unless you want to start diving into some of the options, as opposed to a grammar or graphics approach where you've already defined the x and the y, and changing your geoms is really just a single line here of, do you want a point or do you want a path? Similarly, here's another example where if I wanted to add a log scale here on the y-axis in the Wolfram language, that actually, is a whole new symbol. It's a list log plot, whereas in a grammar graphics approach, it's just an additional line to change the scale kind of at the very end of the graphic. And then lastly, I think where things kind of become a little bit more obvious in terms of some of the functionality that we really want is when you really have some of these data sets, you can do various groupings, and ListPlot or ListLinePlot will do a really good job of handling what you really want to see with that by default. However, if you go to multiple levels, or if you wanted to change something other than the color, or things like the plot markers, or the plot markers, or anything else like that, it starts to become a little bit more difficult to change some of those things by default, and you start very quickly writing a lot of kind of ad hoc code to get some of that accomplished. Additionally, here, so if I wanted to take that XY data and add a linear line to it, just fit the data to a linear line and add that actually into this graphic, one of the ways I can do that is with this epilogue statement, which is not super complicated, but these kinds of things again can start to add up as you create really complex graphics. And if you're in an exploratory data phase, really what you want is to be able to do these things kind of quickly. And then lastly, I kind of use this as an example. I see a lot of these kinds of plots, and sometimes I have to make them myself. And it's kind of a bar plot, but you really want to show it with points instead, and then you can start to add different uncertainty bands on here. And so just creating these kinds of plots where one of your axes labels are really text is something I found more difficult to do with some of the standard functions that are built into the language right now. Okay, so ggplot, as I mentioned, this is an entirely Wolfram language open source project that I've been working on. I actually have not touched it here in a couple of months, but I was working on it pretty extensively towards the beginning of the year. And it's in a proper Packlet distribution, so you can install it really easily from GitHub, and I'll mention some of that here at the end. So the overall syntax, so I've tried to make this as compatible with the way things kind of work in the R world, because there's some good ideas there, while kind of maintaining the Wolfram language-esque type syntax that people would be accustomed to. So the standard kind of input for this is ggplot, your data set, some of your maybe initial aesthetics like X and Y, and then any other additional aesthetics and geomes that you might have. The other way you can do this is kind of fully specify what your data is, which is this data set. And you can do your additional aesthetics and geomes there. I personally use operator forms quite a bit when I'm working in Wolfram language, and I think it makes for more readable code. So I've tried to make that as supported as possible. So you can say, for example, here's my data set, and I just want to pass in, all of the, aesthetics and geomes and things like that. And this is actually a more kind of typical approach that you would do with R as well. So it keeps the code reading very consistent between the two there. Things can also get a little bit more complicated if you'd like. You can define a lot of these options like the data and the aesthetics for individual geomes and kind of mix and match those however you want. And then lastly, there's any of the kind of options you might want to be able to tweak within the graphics, you can pass those in as well. Things like frame label or plot range or even epilogue or things like those are supported as well. Okay, so here's kind of a basic plot. So this is, as I mentioned with the syntax, I'm using this MPG data set. I'm saying X, I want to map to the DISPL variable, Y to highway, and then I'm going to add a geome point to it. So this is just kind of recreating some of those basic plots that I showed originally with the R package. Here again is just to emphasize that operator form, which is actually how I mentioned I like to use this most often. So some of the more advanced cases here, all right, so again, recreating those same examples I used before. So in this case now I want to add color as another indicator here, and I'm going to map that to the variable of class and then add geome points to that. And then finally, to kind of get a fourth dimension in here, I can say size, I want to map that to cylinders again. Okay, so where other things start to get a little bit more interesting is, as I mentioned before, adding things like a linear line or something like that to a plot it takes a lot of ad hoc code. But under this grammar of graphics approach, you can define these aesthetics, and then adding additional geomes is really just something you can do very easily by just appending them to the function here. So in this case, I have a linear line now that fits that data. And then also, if I want to break my data down still by that by the number of cylinders, because these are aesthetics, I can still add geome points, and the colors will break down according to the number of cylinders, and then this geome smooth will also apply based on the number of colors. So things can start to get pretty complicated pretty quickly here, but you can see some of the power that this type of approach gives you. If I wanted to do this instead with an epilogue, right, you have to start breaking this data down yourself into the groups and then doing linear fits on all three of these data sets, and the code for that would become quite large. So similarly, I mentioned changing scales in the R example. So here, just ignore this 2 here at the end. This is not a log 2. It's a log 10. I have some other symbols defined in another package, and I needed to keep those preserved. So I just added 2 here to these numbers, or to these symbols, but you can ignore that. So so here, if I wanted to add a log scale here on my y-axis, I can do that really easily by just adding this keyword. Similarly, if I wanted to do it to both the x and the y-axis, I can do that also really easily. And then here, this is a different data set, not the MPG data set, but one of my values in here is this date, which are actual date objects. And so if I go to plot this as is, those date objects get turned into absolute time by default, and so things look a little weird. but I have an option in here that you can say scale your x-axes based on date, and everything will kind of work itself out that way. Okay, so some of the more advanced use cases. So I mentioned this as an example. Is, sometimes you want to have basically what's a bar chart. You want text to be on some axes, which kind of defaults you to using something like a bar chart. But really, if you wanted something more like points instead of bars, sometimes things like that can be more difficult to do. So in this grammar graphics approach, instead, I have some cleanup code here where I'm calculating the median of each of these different classes of car. But the real code here to generate this plot is, again, I'm just mapping my X to highway, my Y to this text label of classes, and then I'm applying a geom point to it. Some of the things that I'm starting to implement are things like histograms or actual column charts. Some of those things are not as smoothed out as some of the line and point related geoms, though. But histograms are supported as well right now. And then some really neat things I like to use a lot. So if I were to plot how does your city MPG correlate to your highway, something that's really nice to add, and this is not hard to do with an epilogue at all, but it's just to add a parity line in there, and you can do something like that really easily with just adding another geom here, and then similarly, you can add a vertical line geom or a horizontal line geom, specify your X and Y intercepts, and kind of the rest is taken care of for you. So just kind of where it's at right now. So these are the geoms that are kind of been looked at the most and been incorporated into the package. Points, lines, paths, which are essentially lines that have your x-axis data sorted. Smooth, which are the linear lines that I showed before. There's really only linear lines are supported right now. No kind of advanced regression models or anything. And then the parity lines and horizontal and vertical lines. There are tons more that could and probably should be developed into this, and I'll talk about that here at the end. And then in terms of the scale, again, please ignore the 2s here at the end, but you can have a linear scales on your X and Y, log, and date for both X and Y axes. Okay, so yeah, missing functions. So if you notice in some of the R plots, everything that you do, kind of by default, you get a very nice legend. And that's also something that all of the default Wolfram Language functions support, especially when you're working with like data sets in particular. So that is something that obviously needs to be added, and something I'd like to tackle at some point. I mentioned this, the list of geoms is pretty small right now. I focus just on points and lines because those are the things that I tend to plot the most when I'm analyzing some of my own data. But this list could get quite long, and I hope that it would. I think there's a lot of geoms that are supported in something like ggplot that allows you to really make really complicated and nice looking visuals pretty easily. So that would be nice to get to at some point. Faceting. This was really something I hadn't mentioned in the original R kind of examples, but this is really how you add an additional dimension to your data. So when you've kind of maxed out on things like specifying the colors or the plot markers or the size of the plot markers, one of the last things you can do is to facet the data or facet wrap the data, and what that does is it'll create an individual plot for each of the data sets, however you've broken it down. And the nice thing here is, if by default these axes are all conserved in terms of their plot range, so it allows for comparisons to be done really easily. And there's some nice support for this now in some of the newer versions of Wolfram Language with graphics grid and graphics column and things like that. So I think some of this functionality could be much easier to implement with some of those new functions as well. The other nice thing that ggplot in the R world supports is, you can not only map, some of these aesthetics to just the raw variables, but you can include any kinds of arbitrary functions. So like in this case, if I just really wanted to highlight, where is my highway MPG less than 20, something like that is really easy to do with the R package. And I don't have any kind of support for that yet, but I think it could be something that could be done somewhat easily with the code base right now. And then just kind of lastly, I think general robustness, right? If as I start to use this, I run into issues, and I think there's a lot of things that can be improved for sure, and there's a lot of scenarios where uh, I think I'm probably not making the right default behavior in terms of what it was the right default decision in terms of what the right behavior should be, and I think there's some interesting scenarios where some of that can really be improved quite a bit. So lastly, I'll just conclude. I watched Stephen's keynote last night. And I think one of the things he mentioned was, getting more open source packages available and getting more people to work on some of those things. So this is an open source project. I'm the only one that's worked on it right now, but I would really like to. I would really love to have other people kind of help support this. Other people being, Wolfram staff, because I'm sure that they would probably look at some of the code and immediately know ways of kind of improving things that are being done, and as well as academic and business people as well. I think there's a real opportunity for us to create something that's equally as good as what ggplot can provide with something like this, and I think it makes sense that something like this would never really exist in the standard Wolfram language. I think it's kind of perfect for something as an open source package that you can kind of add into the language. So here is my GitHub, AUL89. The repository is ggplot, and that's the full path. And please, if something like this interests you, let me know, and hopefully there's ways that we can get other people involved in it. So that is the end of my presentation. I will quickly jump over here and see if there are any questions. Yeah, there's a question. Are you using graphics under the hood? Yes. So the graphics language within Wolfram is incredibly impressive. And if you're kind of able to navigate your way through the really fundamental syntax there, things like the graphics primitives and lines and things like that, that's really the right way to go. I spent some initial time when I was developing this trying to see if figuring out ahead of time if ListPlot or listline plot or bar chart were the right things to use, and it really got messy really quickly. So if you can go more fundamental than that and work at the graphics level itself using primitives, I found it to be a much better way to do it. Yeah, and there's a second question I think kind of related to that. So yeah, I am, as I mentioned, using primitives as much as possible. And there is no R code being called here. This is entirely written in Wolfram language. Yes, the Packlet is available. It should be on GitHub if you go to that site that repository that I mentioned. And actually, now that I'm looking at that, I may not have actually pushed the Packlet. So I will do that this afternoon. But please, yeah, look at the repository on GitHub, and I'll make the actual Packlet itself available there, so you can easily install this. There's a question about, is the R source useful? I've spent some time looking at it. I am not a very good R programmer, so I tend to spend a lot of time trying to figure out what's going on. I think it probably would be pretty useful to someone that can really read it really efficiently. I found myself kind of coding this up myself in Wolfram language as I go, as opposed to trying to recode up whatever is in the R package. Okay, if there are no more questions, I'll go ahead and stop this now. Thanks again, everyone.